Yeah, hello everyone, myself Maruti, welcoming you all to this math video session. In this video, I'm going to deal, from the last many videos, I'm dealing the same thing, that is linear equation under two variables. Right, as I have been telling you, I'm going to deal with the real life application, number of this, number of that. So we have to get the two unknowns from the real life and we have to try that one. But before trying that one, we have to set two equations. After setting two equations, we can solve either substitution, elimination, cross-section, graphical method, whatever it might be the procedure. But we are supposed to find the value of x and y, the unknowns. So who are the unknowns? What is the real life application? Let us go to the sum here. All right. What he says, in a garden, there are some bees and flowers. So he is talking about two concepts here. Bees and the flowers. Right. You know the bee sitting on the flower for the sake of its food. All right. The bees and the flowers are the two concepts here. Right. So there are some bees and some flowers. Right. If now what is the relation he has given between the bees and the flowers, we have to think of. Okay. So if one bee sits on each flower, if one bee, if you consider this as a flower, and if one bee is sitting on one flower, if this is a flower and if this is a bee coming for and sitting there, that is what he says. So if one bee sits on one flower, one bee is left over. So I will let you know how to set the equation. If one bee is sitting on one flower, one bee is left over, flying in search of a flower. It doesn't have place to sit. Okay. And the second one, if two bees are sitting on each flower, then one flower is left over. If two bees are sitting on each flower, then one flower is left over. Alright, so no one is sitting on that. Now here the question, he has given two relations. I will let you know how to set the equations. So here he says, how many number of flowers are there and how many number of bees are there? So as I have been dealing here, which are the two concepts we are trying to? So I like to call the first concept, the concept 1, right? It's nothing but the concept 1, which is the first concept, right? And which is the second concept, right? Second concept. And I'm going to deal with the logic on which we are going to deal with the steps. Okay. See here, which is now, what is the logic what I'm going to do? To which it is compared, I like to take it as x. To which comparison is done. Comparison is done. I like to take that as x. To which comparison is done. Right. And which is compared, I like to take it as y. Which is compared. Which is compared, I like to take it as y. These are the two concepts always I deal, and it's better for you to think on in this way. Which is compared, to which it is compared, and which is compared. So see here, bees are compared to the flowers, right? The bees are sitting on the flowers. So flowers, so number of bees and the number of flowers. To what we are comparing? We are comparing to the number of flowers. Right. Therefore, I like to take flowers as the first concept. Flowers as the first concept and bees as the second concept. These are the two concepts which you have to. Okay. Now, according to the question, he is asking, how many number of bees are there? How many number of flowers are there? How many? We don't know that. So let us take a number of flowers as x and number of bees as y. That's what we are saying. Let number of flowers be x. Let the number of flowers be x and let number of bees be y. So basing upon the logic, why did I take flowers only as x? Why? Because that's what is it. To which comparison is done. Bees are compared to the flowers. Bees are compared to the flowers. This is the relation what we have. Bees are compared to the flowers. Therefore, the second one, the flowers, I like to take it as x, and the bees, I like to take it as y. Done. So, basing upon the logic what we are dealing, we choose the two concepts. The first concept is flowers, and the second concept is bees. And as we have to find the number of bees and the number of flowers, let the number of flowers be x and the number of bees be y. Yes, this is the introduction topic. So what is what and all. Now what is the relation between? Now we are coming to the second concept. What is that one? Relations. Right, we are dealing with the relation. What is the relation he has given? First relation. Let us know from the question. Pick the sentence. Pick the sentence which gives the relation between the bees and the flowers, the X and the Y. So what's the relation? If you go for that, right, what he says, if one bee sits on each flower, right, we are dealing with the sentence, right, the sentence, if one bee sits on each flower, if one bee sits on one flower, what he says, then one bee is left. Right, this is the relation. This is the relation. If one bee is sitting on each flower, let us take, we don't know how many. Let me take this as a flower. Right, let me take this as a flower. Let me take this as a flower. Just as an example. We are not sure about this. Example. Right, example I like to take. What he says, if one bee is sitting on one flower, if one bee, the blue colored are bees, right? If one bee is sitting on one flower, this is a flower, this is a flower, this is a flower. If one bee is sitting on one flower, one bee is left over, one bee is left, right? One bee is left. Right, he doesn't have space to sit. One bee is standing, just flying there, searching in search of a flower. There are only few flowers. Okay, but this is just an example. We are not sure how many flowers are there. So, right, if I convert this statement in terms of symbols, how to write? So we are counting the number of bees. How many bees are there? Right, so that's what number of bees is equal to how many are there? So number of bees per flower, yes, times number of flowers. That's what. So that's what we are saying. How to total number. This is a formula what we have to remember. Right. Number of bees per flower, right, times the number of flowers, right. And if you check it out, what is we are talking about? Number of bees, right? So is a bee is left over? Is a bee left over? Suppose, right, is the bee. Suppose, see here, how many number of bees per bench or per flower are there? One, yes, that is what he is saying, one. How many number of flowers are there? 3. This is an example. But according to this one, how many number of flowers are there? Here, there are 3 flowers in our example. But in the general question, how many we assumed it as? X. Therefore, it's nothing but X. Now, number of bees, what we are calling it as? It's nothing but Y. Okay, now, so 3 flowers, 3 bees. So, 1 is left over. Shall we add to, just if you take an example, number of flowers, how many are there? 3. So, 1 into 3, 3. Right? How many bees are here? 4. So, 1 extra is there. So, shall I call it as plus leftover bee, leftover for 1 bee. Is it this? Leftover bee. Right. So how many are left over? It's nothing but 1 is left over. Is it cool? So just this is an example I am taking it out. Right. 3 is the example. But how many number of flowers are there? It's nothing but X. So now how many bees are there? So 1 into X plus 1. Therefore X plus 1. 1 into X, and this one is here. This is the first relation what I had given. Okay, cool. Let me repeat it. If 1 bee is sitting on 1 flower, 1 bee is left over, 1 extra. While counting, you have to add this. Don't forget that. So while we are counting this, we have to add that leftover bee. So we have to add that leftover bee, 1. So, but how many flowers and how many bees are there? 1 flower, 1 bee in 1 flower. Alright. So 1 bee on 1 flower. But we don't know how many flowers are there. Therefore, we took it as X. So number of bees is equal to number of bees per flower is 1. Number of bees per flower is 1. And number of flowers we don't know. Therefore we took it as x. 1 into x, the leftover flower. We have to count that one also. We should not ignore that. So 1. So now if you check it out, the relation is between the bees and the bees. Right. So the number of bees, the relation is between the bees and the bees. Right, I can call this as a direct relation. Direct relation he has given. Okay, so with the help of that direct relation which is between the number of bees and the leftover are bees. Bees and the bees. As we are dealing with the bees and bees, I like to call it as number of direct relation. Okay, now let's get back to the second one, relation 2. Yeah, relation 2. Right. So what is the relation 2 he has given? This is the tricky part. What is? If 2 bees sit on each bench, let's go for that. If 2 bees are sitting on each flower, if 2 bees are sitting on each flower, what he says, if 2 bees are sitting on each flower, 1 flower is left. 1 flower is left. This is the tricky part you have to remember. So please remember here, 1 bee, leftover is bee. Bee and bee, relation is between the number of bees and the leftover are bees only. Here, bees and the flower. Here the relation is between, right, bees and flowers. It is not a direct relation. I like to call it as indirect relation. Indirect relation. Okay. So, but whatever it might be, we have to convert in terms of the equation, not in terms of symbol. So, the number of, so just for your benefit's sake, I like to give an example. So, if you are taking this as a flower, right, it's a flower. And it's a flower, and we are not sure how many flowers are there. So, right, how many are sitting on each flower? He is talking about 2 bees. If 2 bees are sitting on each flower, 1 flower is left. Yes, this is the flower in which there is no bees sitting. This is what he is saying. So now if you count it, how many number of bees are there? 4. Number of bees is equal to, this is what the number of bees per flower, number of bees per flower according to the question, right, times number of flowers, right, here, right, what is this, right, what he says, 1 flower is left. What is this? 1 flower is left. 1 flower is left. So shall we add or subtract? How to do? So this is cool part. Let me set the relation here. Number of bees. How many? Why? There is no issues. Number of bees per flower. According to the question, how many bees are sitting per flower? 2 times number of flowers. What we are calling? It's nothing but x. Okay. Now what he says? 1 flower is left. Here we are talking about bees, and here he is talking about flowers. How can we relate bees and flowers? We can't relate in an equation. When we say is equal to, equals, here also we should talk about bees, and this side also we should talk about the bees only. We can't talk about a flower. So as we have to talk in terms of bees, instead of thinking as 1 flower is left, we have to think on how many bees can sit on that flower. How many bees? How many are sitting here? 2. How many are sitting here? 2. How many can sit on that? So 2 can sit. So what I have to say means a place for 2 bees is left over. Right, instead of saying 1 flower is left, I like to call it as a place for 2 bees to sit is left. That's what the logic point. Instead of saying 1 flower is left, I'm saying instead of saying 1 flower is left, as I have to talk in terms of bees, I like to say a place for 2 bees is left. Okay, now how to convert in terms of equation? So y equals, this is cool, 2x. How many b's? Here also b's. 2 into, this is also b's, right? So this 2 b's is left over. Okay, so here we have to take, yes, it's nothing but 2 places, it's left. No one is sitting down there. No one is sitting on that. So if you take, suppose if we are saying 2, 2, 2, if you think how many flowers are there? 1, 2 and 3. 3 flowers are there, right? How many are sitting on each? 2 are there, 2. Right, is it 6? Are 6 sitting? No, the 2, a place of 2 base is left. Therefore, minus 2 we are doing. It's nothing but 4. Right, a place of 2 is left over. You got, I think. So, we have to take away that. So, this is equation 2. Right, equation 1, as the relation is direct, B's and B's, and counting the one which is left over. Here the relation is between the bees and the flowers. Instead of taking flower, I took the place of 2 bees. But they are not sitting. They are not sitting. Therefore, from the total calculation, I have to remove that. From the total calculation, I have to remove a place of 2. Therefore, I have removed it. So, I got the 2 equations. Yeah, so we got the 2 equations now. So with the direct relation, we got, see here, number of bees is equal to, right, 1 the bee sitting on 1 the flower plus the leftover flower. And the second relation, number of bees is equal to 2 bees sitting on number of flowers, and this is the space left over for 2 bees sitting. That is 1 flower is left over. So let's solve that one. So solving equation 1 and 2, there is no issues, directly we can solve it. So let's equate that. So x plus 1 is equal to 2x minus 2, 2x minus x is equal to 1 plus 2, 3 equals x. Right away we are solving it. Now substituting x is equal to 3 in equation 1. There is no issues in that. We straight away get. So y is equal to x plus 1. Y is equal to 3 plus 1. Y is equal to 4. So we may be thinking, yes, it's cool. But verification plays an important role. Verification. Right. So what he says according to, let's relation 1, let's verify. Relation 1, let's verify. What he said? What he said? Number of bees equals, right? What he says, right? He is talking like this, right? So 1 bee for flower, and this is what? Number of bees. So how many bees are in actuality? So what is the actuality? What he says? How many number of x? X what we thought? X is nothing but we are talking about flowers. So he is saying for 3 are flowers, right? So it's a flower. What he says? 3 flowers are there. So flower 1, flower 2 and flower 3. So let us check equation 1. Equation 1. So how many bees are? What is saying? How many bees are sitting? 1, 2, 3, right? If 1 bee is sitting on 1 flower, 1 bee is standing. Okay, so now count. How many flowers are there? Number of flowers, right? Flowers are 3. Yes. How many bees are there? Bees, right? Yes. If 1 bee is sitting on 1 flower, 1 bee is left. Yes, equation 1 is satisfied. Now let's satisfy equation 2. Right, make arrangement according to equation 2. Right, actual, this is equation 1 or relation 1. Relation 1 is satisfied. We have to show this. Now, let's go for the relation 2. Relation 2. What he says, but whatever it might be, number of flowers and number of bees are same. So, how many bees are there? Right, how many flowers are there? It's nothing but 3. That doesn't change. How many flowers are there? How many bees? How many flowers are there? Flower 1, flower 2, flower 3. So flowers are 3. How many bees are there? According to the second relation, what he says? 2 bees should be sitting on each bench, each flower. So 1, 2, 2 are sitting on the flowers, 2 are sitting on the tree. Totally how many are there? There are only 4. There are only 4. So I made 2 and this 2. But now according to the second relation, what he said, if 2 are sitting on each flower, 1 flower is left. So how many bees are there? 4. 2 are sitting here and 2 are sitting here. Is a flower left over? Yeah. So, but we didn't take 1 flower left over. We said the place for 2 bees is left over. Yes, a place for 2 bees is left. Right? So, equation 2 is also verified. This is how to find. But justification with actuality satisfying equation 1 and 2, equation 2 or relation 2 is satisfied. So, now conclusion. So, as it is satisfied, we have to conclude number of flowers or number of flowers, comma, x is equal to 3 and the number of bees, comma, y is equal to 4. This is the relation. But after verifying with actuality, with actual numbers, equation relation 1 and relation 2. Hope you are. In this channel, I have been placing both math and science videos.